So we have a situation in which a point traversed half the distance with velocity v0, the remaining part of the distance was covered with velocity v1 for half the time and with velocity v2 for other half of the time. Find the mean velocity of the point averaged over the whole time of motion. So suppose these are the ends of this circuit, the total distance particle covered. So let us tackle the first v0 problem. It says that half of this distance, suppose first half is s, second half is also s, this was covered with velocity v0, and the other half it is covered with half the time with velocity v1 and other half time with velocity v2. So suppose if there are two time intervals here, t and t, this one was covered with v1 and this was covered with v2. So we know that average velocity or mean velocity is always equal to total distance covered over total time taken. It is simple. So here total distance is 2s, as we can see in the diagram, and total distance can be obtained in such a way so that total time can be obtained in such a way so that this s get cancelled all the way. So total time will be time taken from point A to B plus time taken from point B to C and then time taken from point C and D. So we can say it is equal to S by V0, which is time taken from A to B, plus time taken from B to C and C to D, which is collectively 2T. Now we can't cancel here T and S, so we can also have to write one more equation. We can say that if this total distance is S, this S must be equal to V1 times T plus V2 times T. So T will be equal to S by V1 plus V2. We can use this equation here, so we can finally get the result of 2 divided by 1 by V0 plus 2 by V1 plus V2. This is the final answer for the mean speed in this question. Thank you.